As already introduced, this work is from University of Darmstadt, and the talk is all about satellite security. Specifically, we will provide an overview of the research in satellite security and highlight recent challenges that should be tackled in the future. As a focus, as seen in the title, we will highlight the problems related to location privacy and public key infrastructure. So first of all, let's start with the latest trends in new space. So new space came up lately this term, which is the Industry 4.0 of satellites. And under this umbrella, a few various aspects are important that make satellites more available. So the first is that there are a lot of standards around satellites lately, and also the satellites get smaller and smaller. So here you can see a CubeSat, which is just 10 by 10 centimeters, and you can attach that to a rocket and bring it to the orbit. When you bring such a small thing to the orbit, of course, you also have to pay for it. And yeah, the cost for launching is also decreasing lately. You can see here a chart where you can see the history of the launch price per kilogram, and you can imagine if you have such a small satellite, it doesn't cost too much. So the authors in the paper say that it costs around $20,000 to build and launch a satellite these days. So another thing that is important is the availability of the infrastructure that you need to use satellites. So there are, for example, Spire Lemur and AWS ground stations where you can rent hardware and stuff to communicate with your satellite. So you can already see here that it is really easy to launch a satellite and work with it. Another important point is that, that is under this new space umbrella, that lately the satellites are not, instead of using a few big satellites, there are many small satellites collaborating to provide a service, these LEO satellite systems. So this to be said, we will now come to some recent surveys in the area of space security that are already published, so that you can see what kind of research has already been done in this area. So the first one is there are some studies about protection against GNSS spoofing, so manipulating the GPS signal. Here you can see that there are already a lot of works. Then you can find a study on quantum key distribution, about secure routing in space networks, physical layer space communication protection, and also protection against jamming, eavesdropping, and hijacking. So you can see that these studies are very diverse, and they have already been researched, and some of them have a long history already. However, there are still some less explored challenges that I will come I will come in the next slide. So some less explored challenges arise from the fact that users can now also upload data to the satellites. So since users upload data, you can triangulate the signal and with this detect where the user is. So you can, in fact, violate their location privacy. And this is indeed a problem. For example, if the internet is down in a country and you use Starlink to provide internet, then of course it is crucial that the location privacy isn't violated, because, for example, if a war is going on, you could see where people are located, or you could also potentially target journalists, activists, and other users this way. So hence, you can see this is a highly important problem. And besides that, of course, the satellites communicate under each other. And for this inter-satellite communication, you also need some security, and this can be provided with public key infrastructure. However, if you have public key infrastructure with certificates, you also need to check that the certificate is not revoked at the time of check. And as you can imagine, since you're in the space, this is a problem. This fresh check is hard due to the delays of satellites and also the disruptions that you can have to the ground station. So we have these two problems, and we can say that there's an interconnection between those problems. So public key infrastructure provides trust to the users in space networks. But trust also should not violate the user's privacy, including the location privacy. So the data shared between the satellites should be within a trusted network, and this is provided by public key infrastructure. Hence, also compromised satellites should be replaced. Overall, we can see that these two aspects are interconnected. So one question that arises is, why are terrestrial approaches to these challenges, like from the IoT network domain, are not direct applicable to the space domain? This lies in the characteristics of space networks. So space networks, for example, have limited computational and storage resources. For example, they have strict power budgets. They also have limited bandwidth and connections, for example, when they use low power antennas. They have a dynamic topology, so they are not fixed in space, but they are moving. And there can, of course, be obstructed connections to the ground stations. So all these problems make it, of course, difficult to establish trust in a public key infrastructure. And especially the up-to-date check of the revocation status of certificates is a highly important problem here. So regarding revocation checks, there are some methods that potentially could be applied. There are online certificate status protocol, which is used in the web. But due to disruptions in space and also overhead of the protocol, this is not the optimal solution for satellites. Further, certificate revocation lists, of course, have a large overhead since you have to transmit the whole list and you have limited transmission capacity. Then there's a huge question what commercial players like Starlink do as the systems are closed. And we can also say that the governmental space agencies, they usually use symmetric key pairs which do not scale. And yeah, therefore we can say, okay, there are some solutions to this problem, but there needs to be something new in space. So this is the first problem that needs to be tackled in the future. The second problem, the location privacy, is also not solved. So there are emergency networks, but they do not address location privacy at all. Further, you can use transport layer encryption, but this is insufficient due to metadata correlation. So the same problem also arises for onion routing, which is vulnerable if you, for example, monitor the entry point or the exit point of such a system. You can use these meta information to get some information out of it. So these are also not sufficient here. And there are also mixed network. A mixed network consists of a chain of proxy servers that take messages from different users, shuffles them, and sends them out in random order to the next server. So also some complicated routing. But of course, this is an impractical overhead that should also not be there in the space domain. So you can also see here that the existing solutions might not work in the space domain. There are two works on public key protected satellite-to-satellite connections, one from Huang et al. And one from Matusa et al. But the first one only uses symmetric cryptography, which does not scale. And the second one does not address revocation. So you can see the open problems here. Regarding the revocation check in space networks, you can see that there are a lot of works. We tried to group them and categorize them. We found 8 groups like broadcasting, short-lived certificates, certificate revocation lists, and so on. But just that you see that there are some works. However, all those works, again, have some downsides. For example, the certificate revocation lists, they have a huge overhead, same as with broadcasting. The short-lived certificates, for example, they still leave a vulnerable window. Other concepts make assumptions that do not always hold. For example, the neighborhood vouching, they assume equal trust in the overall network for each satellite in the system. Or blockchain approaches, they assume connectivity to full nodes, which is not always there. So you can see that all of these methods have downsides, and future research should definitely tackle these downsides. For the location privacy, we also tried to come up with categories and categorize the works. So we grouped them into 10 groups, like phantom routing, where messages are first shifted between satellites before they're sent to the base station, or fake traffic, where additional simulated traffic is added as noise to the network. However, also here we could see that there are some downsides. If we look at phantom routing and fake traffic, the second entry that I mentioned beforehand, we have again overhead. And in many other rows, you can also see that overhead is a huge problem here. And some others like this avoid adversary makes assumptions that you know where the adversary sits, or ring routing, for example, cannot be applied because satellites are not arranged in a ring. So you can also see here that this problem is still open. So overall, we can say that there are two research domains that are open in the space domain, which are revocation checks and location privacy. And for revocation checks, one could potentially use multiple CAs, or further, one could leverage the predictable topology of satellites to improve security of revocation checks. So these are two ideas that can help to tackle this problem. Lastly, one could also evaluate existing or such new systems that might be developed in realistic space networks or respective simulations. So there's also a need to do that. For the location privacy, one could try to conceal the user's signal to hamper triangulation, which is of course really important. You can use physical security for that. Further, one could evaluate the threat so the location privacy threat when considering internal attackers in a satellite network. So what happens if a satellite is compromised? And additionally, fake traffic that is optimized using the predictable orbits are promising. So if you know where the satellite will be at a given time, perhaps you can use this to add optimized fake traffic. Lastly, one could try to design an onion-like routing optimized for satellite internet. So these are the research ideas that came up during writing this paper, and I hope this gives some ideas for research that needs to be done in the future. And with this, I thank you for your attention. And as said, you can try to ask questions, but if it's too complicated, perhaps I forward you to the authors. Thank you.